All right, good morning, everybody. We're going to talk today about scale factor. Last time we talked about scale. So our question is, how is scale factor different from scale? So here's what it is, and it might take a couple examples to get the difference, um, but let's give it a shot. So scale factor is when you take the scale and you write it as a unitless ratio. Okay, when we were doing scale, remember units were very important. We had something like 1 inch equals 2.5 feet, or 1 centimeter equals 3.5 miles, something like that. So it was inches to feet, inches to miles, whatever it was. But with scale factor, we want to write it as a unitless ratio. Okay, in order to make it unitless and drop the ratio, to drop the units, what we need to do is make sure the units are the same. Okay, if they're not, we need to convert. So what we're basically doing here is our scale factor is going to tell you how many times bigger something is in real life than it is on the scale. Is it twice as big, 3 times big, 100 times as big? Okay, so that's what we're after here. So if I look at this example, this is a scale. 1 inch to 3 feet, that's a scale. Okay, maybe 1 inch on my model is 3 feet in real life. Now, I want to know how much bigger it is in real life than the scale, but it's not 1 to 3, it's not 3 times bigger, right? Because this is feet and this is inches. So in order to answer this question, I got to do some converting. Okay, so what I can do is I can turn the feet into inches. So if I multiply by 12, I get 3 feet is 36 inches. Okay, now that it's inches on top and inches in bottom, they can cancel out, and my scale factor is 1 to 36. Okay, so the scale factor in this example would be 1 to 36, meaning it's 36 times bigger in real life than it is on the scale. Okay. All right, so let's look at some of the scales we came up with last time and turn them into scale factors. Okay, so the Statue of Liberty one, we got a scale of 1 inch to 15.25 feet. If I want to make that a scale factor, what I want to do is I want to convert so that they are the same units. Okay, so I have inches and feet. It's going to be easier to turn the feet into inches because I'd be multiplying than to try to turn this 1 inch into a foot, because then I'll get a decimal. Okay, so I'll leave 1 inch on the top, and I'm going to turn this into 15.25 feet into inches. Okay, because there's 12 inches in a foot, I just got to multiply that by 12. So 15.25 times 12, here's an example of how we would show that work, equals 183. That's 183 inches. Okay, so the scale factor is 1 to 183. Okay, it's 183 times bigger in real life than it is on the model. Okay. All right, so here's one from Miss Morehauser. Okay, we got a scale of 1 centimeter is 2.5 meters. Okay, remember, there's 100 centimeters in 1 meter. Okay, so using that information, I'm going to pause it here and see if you can come up with a scale factor for this one all on your own. All right, so give that a shot, and then we'll resume. See if you're right. All right, welcome back. Hopefully the scale that you got was 1 to 250. Okay, so there's 100 centimeters in a meter, which had to multiply this by 100. That gave me 250 centimeters, okay, as opposed to 1. So once the units are the same, we drop them. This tells me it's 250 times bigger in real life than it is on the model. All right, let's try this one. So for the dinosaur models, we got 1 inch was the same as 1 point. And if remember, this was 1.3 repeating feet. Okay, now you may recognize that 1.3 repeating as 1 1/3. Okay, I'm bringing that up because if I do 1.3, I won't get quite as nice of a number. Okay, and it won't be exact. So if I go back to the exact answer, which was 1 1/3, if I want to turn this into a scale factor, again, this is in feet, I want it in inches, so I have to multiply by 12. I can use what I know about fraction multiplication. Okay? Remember, whenever we have a mixed number, when multiplying fractions, I got to make it an improper fraction. 1 times 3 plus 1 is 4. I get 4 thirds. I'm going to multiply that by 12, which I'll write as 12 over 1. Okay. Now, before I do any multiplying, I can reduce. Okay. I see 3 and 12 can both be divided by 3. Give me 4 and 1. Okay. I see all 1's on the bottom. That's good. It means I'll have a whole number. 4 times 4 on top is 16. Okay. So I get 16 inches on the bottom. Okay, once I have inches and inches, I can write my scale factor as 1 to 16, a unitless ratio. Okay, so it's 16 times bigger in real life than it is on the model. All right, so let's have a quick vote. Looking at this one, who do you think is right? Vote, and we'll see if you're right. All right, so hopefully you voted for Melissa. Melissa was right on this one. Okay. If it's 1 inch to 4 feet, well, we got inches and feet. We can't say that's a 1 to 4, right? 4 feet is not 4 times bigger than 1 inch. Okay, it's more than that because feet are bigger than inches. Okay, we got to make this inches, which is 48 inches, and then it's 1 to 48. All right, so let's have you do a couple of these. All right, so I'm going to pause the video here, see if you can find the scale factor for each one. Okay, then we'll unpause it, and I'll go through it and see how we did. All right, welcome back for this first one. We've got inches and feet. Again, I've been using those a lot. I got to turn this into inches by multiplying by 12. 15 times 12 is 180. So 1 inch to 180 inches, I can drop the units. The scale factor is 1 to 180. Again, it's a ratio, so we could write it with a colon. We could write it with the word 2 or as a fraction, either one. Okay. For this one, we got centimeters and meters. Again, I'll make this 250 centimeters, multiply by 100. Then I have 10 to 250. Okay. But like always, it's a ratio, which means we want to reduce it if we can. I can divide both those by 10. I get 1 to 25. Okay, it's nice we can get the 1 on top, so we can just say it's this many times bigger in real life. Okay, so hopefully those are the ones you got. All right, let's take a look at some ones. I think you got some like this on your homework. Let's take a look at what we're supposed to be doing here. So here it says to identify the scale factor. It gives me the length of the toy and length of the real thing. Okay, so I can write a ratio, 3.9 inches to 249.6 inches. Now I got the same units. That's nice. That can go away. But if you remember what we did with simplifying things like this isn't very simple right now because it has decimals in it. So if I want to simplify this, I can move the decimal point over, as long as I move it the same on the top and bottom, and then I can try to reduce. Okay? So if I move the decimal point over 1, I will get 39 on top and 2,496 on bottom. Now, I can do some trial and error with this. It's not going to be super obvious to reduce right away. I can use, what I would check first is I would check to see if this goes into this. If 39 goes into this number, that'll be real nice because I'll have a 1 to something. So I'm going to take my calculator and do 2496 divided by 39. When I do that, I actually do get a nice whole number. I get 64. So if I divide the top bottom by 39, I get 1 to 64. If that didn't work, you could play around, use your divisibility rules, try to reduce this as much as you can, and you would eventually get it down to 1 to 64. So that's the scale factor. The actual truck is 64 times bigger than the toy. Okay, I can do the same thing for this one. 15 to 190. The units are already the same, so I don't need the units, but I do want to reduce these. I can see they're both divisible by 5, so I'll do that. So 3 into 38. Okay, and I want to see if I can reduce that more. I know 38 isn't divisible by 3 because I can add a 3 plus 8 and get 11. That's not divisible by 3. So this is as far as I can go. So 3 to 38 is my scale factor. That's less nice because I can't just say it's so many times bigger. I'd have to make this a 1 in order to do that. But that's okay. 3 to 38 is an okay scale factor. All right, so a lot of the ones your homework are going to look like this. We're going to do one together to make sure you know what to do. So when you see this in your homework, it tells you that the scale model is 1 to 16, or scale factor. So remember what that means is that it's 16 times bigger in real life than it is on the model. Now we could set up a proportion using the scale and some of these things if we wanted to, but because it's a 1 to 16 scale factor with a 1, and we know it's just 16 times bigger in real life, we can just solve all these problems by just either multiplying or dividing by 16. Okay, so for the barn, if it's 32 feet in real life, okay, to get the model height, well, we know the model is just going to be 1/16 of this size. So I can divide this by 16 to get 2 feet. Okay, if it's 3.5 feet in the model, to get the actual length, I would just multiply by 16. Okay, so if I do 3.5 times 16, I get 56. Okay, so in these examples, if you know the scale factor, if you're given the actual dimensions, just divide by 16. If you're given the model dimensions, just multiply by 16. Okay. For the submarine, it has a length of 18 3/4. Okay, and I'm going to multiply by 16 to get the actual length. Okay, again, I'm given the model, so I multiply to get the actual. If I was given the actual, I divide to get the model. Okay, so a couple ways I can do that. I could remember my fraction multiplication, turn this into an improper fraction, and multiply. But I have other tricks up my sleeve. I know 3/4 as a decimal is 0.75. So I can do that conversion and just multiply on my calculator. So 18.75 times 16 is 300. So it's 300 feet in actual length. Okay? So that's what you're doing for those. You're either multiplying or dividing by 16, depending on what you are given. All right, that's all I got for you. Give it a shot. Let me know if you have questions. Good luck.